In this chapter, we're going to look at topics related to measurement. In this lesson, we're going to look at the perimeter and area of two-dimensional figures. All right, hi everybody. So in this lesson, we're going to take a look at perimeter and the area of two-dimensional figures. Okay, so first of all, we're going to define polygons. Okay, and the features of polygons that are pertinent to what we want to do here. So now a polygon is just a two-dimensional enclosed figure. Okay, enclosed meaning there's an inside and an outside, right? So like I've got three sides here, but it's open. That's not a polygon. As soon as I close that off with these straight sides here, that becomes a polygon. So it's going to have straight sides, at least three. You can't have less than three, and you can have as many as you want there. Two-dimensional means that it's flat, so it's got length, it's got width, but there's no depth. Okay. Polygons are given different names according to the characteristics of their sides and angles, just like it says here. And you're going to be familiar with a few of these, but we just want to introduce you to maybe some that you less familiar with. So, for example, you know a three-sided polygon is going to be a triangle, right? And we classify those as right, acute, or obtuse by their angles. Okay, right? So we have a right angle triangle's got a 90-degree angle. If none of the angles, okay, are 90 degrees or greater, it's acute. And if one of the angles is greater than 90 degrees, okay, and I can only have one in there that's greater than 90 degrees, then we're going to call that obtuse. So those are your three ways of classifying it by angle. Or you can classify it as equilateral, in which case all the sides are the same. Isosceles, okay, in which two of the sides are the same, but the third one is different. And then in a scalene triangle, all the sides are different. And those are your three ways of classifying it by sides. Then we've got quadrilaterals. Now, quadrilaterals, there's a whole bunch of different quadrilaterals here. Okay, we can have a square where you've got four congruent sides, four 90-degree angles. Okay, but you know what a square is. I mean, you are familiar with a square. All the sides are the same. In a rectangle, you've got two pairs of congruent parallel sides. So what that means is, in here, part of what's important in that definition of the square is the four 90-degree angles there. So in other words, you have it set up here so that these two sides are parallel and these two sides are parallel. In a rectangle, you've got a similar sort of thing where the opposite sides are parallel, okay, but they're not the same length here. But there's still 90-degree angles in here. We change the definition, or should we say change the name of it, once we change the restriction here that has to be 90 degrees, because I can still have opposite sides be parallel and not have it be 90 degrees, and that creates a parallelogram. So when you've got two pairs of sides that are the same length, okay, and then opposite sides are parallel, that's a parallelogram. If they're all four congruent, then what you've got here are is a rhombus here. So a parallelogram where all the sides are the same is going to be a rhombus. Just like we have a rectangle and a square. It's basically the same sort of difference there. And a trapezoid, you're going to have two parallel sides, and then the other two aren't. Okay, so this side is parallel to this one, and those two aren't here. Now, if these two sides are the same length, we call it an isosceles trapezoid. And if you've got a trapezoid that looks something like this, where you've got a right angle in it, then we would call it a right trapezoid. In any case, not a big deal. But there's several options there when we start talking about quadrilaterals. If it's got five sides, we call it a pentagon. And then now you're going to see the same thing happening over and over and over again here in just a quick second here. A regular pentagon, all sides are congruent, all angles are congruent. If it's not regular, then the sides and the angles can vary. A hexagon, a regular hexagon, all sides are congruent, all angles are congruent. Non-regular hexagon, sides and angles can vary a little bit. And so on with a heptagon, 7 sides, octagon, nonagon, and then a decagon. And it goes on and on. Okay, we can add basically as many sides as you want here. So anyway, now let's take a quick look at a different property of polygons. Okay, so now that we've named the polygons here, now let's take a look at a couple of other properties here, their perimeter and their area. So the perimeter, that's just a one-dimensional linear measurement. It's the distance, okay, around the outside of the polygon. It's like if you had a polygon, a big polygon out in your yard and you had to put a fence around it, how long would that fence have to be? That's your perimeter, okay, if you were going around the whole entire thing here. And so our units of measurement are going to be our linear units of measurement. So our inches, feet, yards, meters, centimeters, and so on. I mean, if it's big enough, we could use hectometers, miles, kilometers, whatever it is that we need to use, whatever the most appropriate unit would be. So for any polygon, it's just the sum of the lengths, okay, of the sides of the polygon. Now, if it's a circle, okay, remember that the formula for the circumference of the circle, or the perimeter of the circle, okay, but in the case of a circle, we typically call it a circumference, is going to be pi times the diameter, or 2 pi r. Okay, so just that little thing here that you want to kind of lock away aside in your brain there. Just remember that you do know the equation for the perimeter of a circle. Another thing we want to look at here is the area. Okay, how much two-dimensional space does it cover? Okay, so if you were, for example, thinking about let's say, putting flooring in your house or in a room here, okay, the amount of flooring you need is the area of the floor. And we're going to measure that in our linear units squared. Okay? So finding the area involves locating the length and width of the polygon. Now that's part of it. It can be a fair bit more complicated than that. But yeah, length and the width of the polygon. The way we calculate it's going to differ from polygon to polygon here. So that's what we want to do here. We want to make sure that we've given you some examples of how to do this. But typically what we're going to do here is, if you've got two sides here, a length and a width that meet at 90 degrees, we're going to look for that box, because then finding the area of the box here is really just about multiplying length times width. So for example, for the rectangle, it's just that, length times width. For a square, it's the same thing, length times width. It's just that in the specific case of a square, the length and the width are the same thing. They're both the side length of the square. For a parallelogram, okay, it's going to be base times height. So it's the length of the base times the height. And you might think of that as, you drop your height right there, and it is perpendicular to the base. So again, in essence, it's length times width here. It's just that in the case of a parallelogram, it's just knocked off to the side there. Now, and by the way, notice as we go through this, some of the notation here. Area, and then we have this little subscript here. This is meant to be like dropped slightly below the A there, the capital letter A, just so that it identifies what we're finding the area of. Just want to kind of highlight that, make sure you're aware of that. For a triangle, okay, remember that the area of a triangle is 1/2, okay, your base times your height. So based on what I was just doing here, if I did base times height, that would be the area of the whole thing. Well, the area of the triangle is going to be half of that. So whether you multiply the base times the height and divide by 2, or take 1/2 of base times height and just multiply it through, it'll get you the same result. There's the formula for the area of a triangle. For a circle, we were just looking at the formula for the circumference of the circle a moment or two ago. Now it's going to be pi times r squared. So we got to get that radius there, square it, multiply by pi. There's the exact area of the circle. Now, anytime you use pi in your calculator, I want to encourage you to try to use as many of the decimal places as you can, because it'll help you avoid rounding errors. Okay, I said a moment ago that we'll get you the exact area here, but that's only if you leave the symbol pi in there. That's exact. As soon as you type that in the calculator and you get a decimal, at some point there you're going to have to round, and then your area is not perfect. It's not exact anymore. But it'll be as close as you need it. For a trapezoid, this might not be obvious here, but with a trapezoid, what you're going to do here is you're going to take the length of the base and then the length of the other base. So the two parallel sides here, we're going to call those the bases, base 1 and base 2. What we do is we add those together and divide by 2 and then multiply by the height here. So you're going to see sort of this triangle formula show up in here. And really, it's almost like having two triangles that we're adding there. One with a base of 2, the other one with the base of 1 there. And in fact, you might even see it like this. If I draw a line like this, okay, then I've got one triangle here whose base is 1. Okay, and then I've got another triangle here, if you kind of flip this around, whose base is this B2. And in both cases here, the height is h. And so that's really why that works the way that works. Okay, so if you're going to find any area here, it involves really 3 steps here. What I need you to do is you're going to state the formula, you're going to substitute the numbers in, and then we're going to state the answers with units. We want to make sure that we're throwing the units in there. That's an important step in this process, is to make sure that you've communicated those units properly. Okay. Now let's just take a look at some examples. So to start off with, we're going to find the perimeter and area of this shape right here. Now the perimeter, okay, perimeter is going to be an easy one. So it's just the sum of the sides going around here. And so what we've got here is we've got a 5, we've got a 10.6, we've got a 5, and then because this is clearly a rectangle with the 4 right angles there, this also is going to be a 10.6 over here. Okay, and so what we've got here is, well, okay, 5 and 5 is going to be 10, so 10, 20, 30, and then the 0.6 and 0.6 is going to be, that's going to give us like 31.2 kilometers. Area is length times width, okay, and so length times width here, our length is going to be 10.6 kilometers. And our width here is going to be 5 kilometers. And so let's just go to the calculator and we'll multiply that out here. So 10.6 times 5, and we get a nice 53 kilometers squared. Okay, because we got kilometer multiplied by kilometer, going to be kilometer squared. Here, this next one, find the perimeter and area. Once again, perimeter is going to be the sum of all the sides here. Now in this case, we can cheat a little bit here. We can do like 2 times the length plus 2 times the, let's say, the width here, although that's maybe not clearly what's going on with the parallelogram. But our length here, we could call 16.6. There's going to be 2 of those. Okay. And then we're going to have 2 times the width here. Well, it's going to be 11. So then 2 times 16.6, whoops, so just on the calculator here, 2 times 16 plus 0.6 plus 2 times 11, and we get 55.2 feet. Now remember, the area of a parallelogram is going to be the base times the height. The base here is 11, and the height, 11 feet, and the height, okay, the height isn't the 16.6. That is off at an angle here. If, in fact, look at this triangle here, that's the hypotenuse here. The height of that triangle is 10.9 feet. So it's just important that you're grabbing the right value there. So the actual base of the parallelogram is this side right here, and the height, okay, when you build that right angle triangle, the height is the distance from the bottom to the top there. So 11 times 10.9, and we get 119.9 feet squared. Squared because we're looking for area. Okay, let's keep going here. All right, for this next question, we got a little bit of work to do here. Okay, we're going to start with the perimeter. So I know that this side here is 5.4 yards. I know that this side right here is 3.7 yards. But I don't know this side right here. And it's going to take me just a little bit of effort to figure out what that side is. I do know that the height here of the triangle is 2.2 yards. So I can use that, actually, to help me figure out what this missing side is. But it's going to take a little bit of a jump around here to do it. So first of all, what I'm going to do is I'm just going to ignore the fact that there's a 3.7 down there just for a moment. I'm going to call this whole side here of this right angle triangle here, we're going to call that x. Okay? Now I'm going to use the Pythagorean theorem to figure out what that side x is. So I know that x squared plus 2.2 squared is going to equal 5.4 squared. Okay, there's my Pythagorean theorem applied to this larger triangle. I'm ignoring this. In fact, I'm even ignoring this side right here, really, that I want, just to look at the large triangle here. So x squared is going to equal 5.4 squared. I'm going to subtract the 2.2 squared from both sides to get the x squared by itself. Okay, now I'm going to go to my calculator. I'm going to evaluate that. And I'm going to get 5.4 squared minus 2.2 squared. And I get 24.32. But remember, that's x squared. So to get x, I take the square root of that, 24.32. Take the square root of 24.32. And I get approximately 4.9. Now I'm going to go to the nearest tenth because the question seems to go to the nearest tenth. So 4.9 yards. Now, when I use this calculation here, though, I'm actually going to leave this entire number in there. Okay, so the calculator is going to use the whole number, but I'm only going to write it down as 4.9. Now, what I want to do is I want to move in from this large triangle into this smaller triangle here. So now I know that this whole length here is 4.9. To get this little bit right here, let's call this y maybe. To get that little bit there, I'm going to take the 4.9 and I'm going to subtract, and I'm going to get rid of that little cross out that I made there. I'm going to take that 4.9 and I'm going to subtract 3.7 from it. Because 4.9 is the whole length, I'm going to subtract the 3.7 and to see what I'm left with. And I'm left with y is approximately equal to 1.2. Once again, I'm going to leave that entire decimal in my calculator, but when I write it down here, I'll write it down as approximately 1.2 yards. Now, I can focus my attention specifically on this triangle right here. Okay, I know what the height of this right angle triangle is. I know what the bottom length is. So what I'm going to do is I'm going to use this to figure out what my hypotenuse is. So 2.2 squared plus 1.2 squared, I'm going to use the number that's on my calculator, is going to equal z squared. That's what I want. So first of all, I'm going to square that number right there. I'm going to add that to 2.2 squared, and I'm getting 6 point, let's say approximately 4 is equal to z squared. So I'm going to take the square root of that number right there, my answer, and I'm getting approximately 2.5 yards is equal to z. Okay, finally, that's what I needed to be able to do the perimeter here. So I'd had a little bit of work here in this question. So the perimeter of this problem is going to be the sum of the sides. So that will be 5.4 yards plus 3.7 yards. But now I can add my 2.5 yards. Okay, so I'm going to take that number right there, and I'm going to add to that my 5.4 yards and my 3.7 yards. And I know that my perimeter is approximately equal to 11.6 yards. Now the area is going to be a little bit easier to figure out. My area, because this is a triangle, is going to be simply 1/2 base times height. And in this particular case, I know the base of the triangle. Okay, it's not this large one, x. It's the line 3.7 here. So 3.7 yards. And my height is 2.2 yards. So now I can just multiply that out. I don't need to worry about anything else here. So 0.5, okay, 1/2, times 3.7 multiplied by 2.2, and we get, approximately 4.07 yards squared. Okay, good. Now let's take a look at the circle. Okay. Normally, when I'm working with a circle, instead of working with the diameter, and I have to assume that that's what they're trying to give here, I like to work with the radius here in both cases there. So if the diameter here is 8, my radius is going to be 4. So my circumference is going to be 2 times pi times 4 meters. Okay. Whoops, and I can just go to my calculator. Sorry, it slipped out of my hand there. So 2 times pi times 4. And we're getting approximately 25.1 meters. My area is going to be pi times the radius squared. And so pi multiplied by the radius 4 squared. And we get approximately 50 point, well, let's round to the nearest tenth there, 3 meters squared. Again, because I'm squaring the radius. And so my units also get squared. Good. Take a look at the next one. Let's find the perimeter and area of this trapezoid. Okay. Well, we've got a similar sort of a situation going on here where there's some information that's missing that I'm going to need to be able to answer this problem. Okay? I need to know what this length is. This is going to take me a little bit of work to figure out because notice that this is a little bit offset. It's not quite this nice symmetrical shape here, so I'm going to have to kind of fiddle with this a little bit. So my perimeter, if I come over here, my perimeter, when I write it out, is going to be 5.9 yards plus 4.7 yards plus 2.1 yards plus, okay, whatever this turns out to be. Now we got to take a quick look at this. So what we're going to do here is we're just going to take this 2.1, this side right here. I'm going to draw a line straight up to here. Okay, my problem is I don't know how big this piece is right here so that I can figure out what this is. And it's going to take me a little bit of time here. I know that this length right there is going to be 2.1 yards. But I don't know how much this is. So I'm going to call this little piece here x. Okay? Now, to get x, I'm going to use this right angle triangle, and I know that this height here is going to be 4 yards. So I know that x squared plus 4 yards squared is going to equal 4.7 squared. So x squared is going to equal 4.7 squared minus 4 squared. So I'm just going to go to my calculator. Let's figure that out. 4.7 squared minus 4 squared, okay, is 6.09. And then I'm going to take the square root of that. Whoops. The square root of that. Okay, so I'm going to get that x is approximately equal to 2.5, roughly. Now, I'm going to still use this number that's on the calculator here, but I'm going to write it as 2.5. So I know that this is 2.5. I know that this length right here is 2.1. So let's call this little distance here y. Y is going to equal 5.9 minus 2.1, what I'm given here, minus that 2.5 that I just used, or I just found. So 5.9 minus 2.1 minus that length that I just found, and I'm going to use that on my calculator like this so that I didn't round it. And I'm going to get about 1.3. Okay, so y is about equal to 1.3. Okay, great. Now I can use that to figure out what my z is. Okay, so that length right there. So I know that 4 squared plus y squared, or this 1.3 squared, is going to equal z squared. So 4 squared plus that answer squared is going to equal, okay, so 17 roughly 0.8. And when I take the square root of that, because that's what I got to do at the end of this Pythagorean theorem here, I'm going to get approximately 4.2. So 4.2 is equal to z, approximately 4.2 yards. So now I can come back over to my perimeter and write 4.2 yards down. Okay, yards. Overlapping a little bit there, but anyway. So then this is going to become 5.9 plus 4.7 plus 2.1 plus, and there's that 4.2. So I'll just do second answer to get that. Whoops, sorry, I'm a little bit off kilter there. And we get 16.9 yards. $16.9 yards. Now, to find the area, well, the area is going to be a little bit easier. It's just simply going to be 1/2 the sum of the two bases, so 5.9 yards plus 2.1 yards, multiplied by the height. In this case, we already know that to be 4. So this is a whole lot simpler here. So 1 divided by 2 multiplied by the sum of the two bases, so 5.9 plus 2.1, whoops, 2.1, multiplied by 4. Oh, that worked out beautifully. We got 16. So 16 yards squared. Good. So it took us a little bit of work, but we got there. Now let's take a look at this one. Find the dimensions indicated. Okay, so what we know here is we know what the area is, and we're trying to figure out what this piece is right here. Well, that's actually not too bad, because my area formula, 1/2 base 1 plus base 2 times the height. If we plug into our area formula what we know, and that's really what I got to use here because I gave you the area, 46.6 is going to equal 1/2, okay, 3.7, plus, okay, well, that's the whole point. I don't know what that second base is. But I do know that the height is 6.3 kilometers, so 6.3. Okay, so now, in order for me to figure out what the base is, I need to simplify or to move over some pieces here. So the first thing I'm going to do is I'm going to move over the 1/2. Okay, so to get rid of the 1/2, I'm going to multiply both sides of the equation by 2. Now, on the right-hand side, all that's going to do is get rid of my half. That's the reason why I'm doing it. But on my left-hand side, I'll get 46.6 multiplied by 2. So 93.2. Then I'm going to take both sides of the equation. I'm going to divide by that 6.3. Now, on the right-hand side, all that's going to do is get rid of my 6.3. But on my left-hand side, it'll be 93.2 divided by 6.3. Okay, and I'm getting 14.8 when I round that. Again, I'm going to leave it like that for now, but over here I'm going to write it rounded to the nearest tenth. And now I'm going to subtract 3.7 from both sides. Okay, from both sides of the equation. On the right-hand side of the equation, all that's going to do is get rid of the 3.7. On the left side, that's going to give me 11 point... Okay, now when I round that to the nearest tenth, it's going to be 11.1 yards, approximately. And so that's what we're missing right here, is a measure of 11.1 yards. And this one down here, again, find the dimensions indicated. Well, what we're missing here is the height. Okay, but this is a parallelogram, and the area of a parallelogram is just base times height. Now, I know the base. So actually, this is going to be pretty straightforward. I know the area is 36.8, and I know that the base is 9.2. So in order for me to get the height by itself, all I have to do is divide everything through here by 9.2. Now, on the right-hand side, that's just going to leave me with an h. Okay, 9.2 divided by 9.2, it just becomes 1 times h is h, so it just cancels. But on the left-hand side, it'll have to be 36.8 divided by 9.2. And I get a nice 4 feet as the height, as the missing dimension in this particular problem. Right, for this last little section we're going to take a look at the area of composite 2D shapes. So, if the shape is not a basic polygon like we've seen above here, then chances are, like it says here, you can divide it up into those shapes here. So the area of the entire shape is just going to be found by finding the area of those smaller pieces and adding them together. Or subtracting them, depending on how you want to do this. So for example, for this shape right here, this little L shape, I can cut along right there, take that piece apart, and then find the two areas and add them together. Or what I could do is I could take and find the area of the whole bit right here, find the area of this piece right here, and then subtract it. Either way, I'm going to get the same area. In any case here, that is the whole idea behind what we're about to do. We're just going to look at a shape here, and then we're going to break it up and either add the pieces together or find the whole and subtract the pieces that we need to get rid of. Okay, so for this question, it says find the perimeter and the area of the room below. So we're assuming it's this shaded bit right here. Okay, well, first of all, the perimeter is going to be pretty straightforward. The perimeter, we're just going to add all of the sides together. So we've got 15 feet here. And then I got to assume it's squared off here. So if this is 11, then this is going to be 11. So plus 11 plus 6. Okay, if this is 7, this is going to be 7 right here. So 7 plus... Oh, okay, well, wait a minute. I don't know what that is. So let's put an X here. Let's just think about this. Okay, this is 6 and this is 6. Okay, that helps us out here. If this is 6 and this is 6, together that's 12. When you compare that to the 15 up top here, that means there's 3 that are missing. So 15 minus that 12 is going to give me 3. So this little piece right here, x is 3. And then just come down here, 7 plus 6 plus 11. All right, well, now that's easy enough. We just got to plug that into the calculator. So 15 plus 11 plus 6 plus 7 plus 3 plus 7 plus 6 plus 11. And we get a perimeter of 66 feet. Now, my area, on the other hand, a little bit more complicated to figure out. I think what I want to do here is I'm actually going to do this. I'm going to close this off. And I'm going to find the area of the whole thing, because that's pretty easy to do. So I'm going to find the area of the large. Whoops, I don't know why it looked like that. I'm going to find the area of the large, and I'm going to subtract here the area of the hole that would be in it. So the length and the width here, length times width minus length times width. This is going to be 15 multiplied by 11. So the length of the room, width of the room, if we were to include this. And then we're going to subtract the length and width of this piece. Now, the fortunate thing is, okay, I know that the length here is 7, but I just figured out what the width was. We knew it was 3. Okay, I used that when I figured out the perimeter. And so now, I plug in 15 times 11 minus 7 times 3, and we get 144. And remember, we got to put our units in here. This is going to be feet squared because we're talking about area. Now, let's take a look at this next one. Okay, so Jerry is building a circular fire pit and wants to fill the shaded region in the diagram with bricks. We're going to calculate the area that he will cover in bricks. So we get that this distance right here is 8 feet, and then the radius of this little bit right here is 1.75 feet. Okay, so I think what we need to do here is we're going to figure out what the area of the whole thing is, including this area right here. Okay. And then what we'll do here is we'll subtract the area of that little bit. Now, it also tells us that bricks cost $25.49 per foot squared. So we're going to figure out the cost of the bricks. Okay, so that's going to be our last step here. But to start off with, we need to figure out what the radius of the big circle is. And the radius of the big circle is going to be 8 feet plus 1.75. So that works out pretty nicely to 9.75 feet. Okay, well, the area is going to be the area of the large. I did it again. I keep wanting to put a T there. I have no idea why. Large minus the area of the small here, or the area of the whole. So that's going to be pi multiplied by the large radius here, so 9.75 squared, minus pi times the radius of the small circle, and they give that to you, 1.75 squared. Okay, so now we can enter that in. So pi times 9.75 squared minus pi times 1.75 squared. And we're getting approximately 28. I was going to say 28.9. 289 point, okay, 023. Sorry, 026. 03 is what I'm going to write down there. Feet squared. Now, to figure out the cost of the bricks, I need to buy the bricks per foot squared. Now, here's the thing. It's not perfect. You might look at that and say, you're so dangerously close to 289 feet. Maybe I'll just fill in the gaps with some mortar around there and I don't need to do it. But most of the time, when you get a situation like this where you're a little bit over, what you do is when you purchase it for purchasing, okay, you have to round up. So what I'm going to do here is buy 290 feet squared. And so the cost is going to be 25.49 multiplied by 290 feet squared. So 290 times 25.49. This is going to cost me $7,392.10. Okay, which is an awful lot of money. But there you go. That's what the math tells us.